for number 17. When we test our value, -2, I get zero over zero. So this is a problem. It feels like factoring is the way to go, and that is going to be the way to do this problem, but to factor x cubed plus 8, you need to remember a formula that you learned algebra 2, probably. And there's two of them. There's sum of cubes and there's difference of cubes. If I wanted to use one of these factoring formulas, like let's say for example I had x cubed minus 125. So I know it's difference of cubes because x cubed is a perfect cube. 125 is a perfect cube, it's 5 cubed. So I would follow, because there's a subtraction in the middle, I would be following this line here. And I would be plugging in x for A and 5 for B. So that factoring would look like x minus 5 times x squared plus 5x plus 5 squared is 25. And that's how I would factor that. So if I take that information and if I try to apply it to this problem with x cubed plus 8, what that's going to look like, x plus 2, I can't do anything to the numerator. That's as simplified as it's going to get. X cubed plus 8, we're following the top formula over here, where x is A and B is going to be 2 because 2 cubed is 8. So we're plugging in 2 for the formula and I'm following along with this. So I have x plus 2, and then I have x squared minus 2x plus 2 squared is 4. Remember that our goal is to reduce. I would have 1 over x squared minus 2x plus 4. Now, after we've reduced it, we always try to plug in the value again. 1 over negative 2 squared plus 2 times negative 2 plus 4. I'm looking like 1 over 12. All right, last problem. We have fractions and fractions, so we should be thinking that this is a common denominator problem, and it is. To be safe, I'm going to do my little check. So when I plug -4 in for x, 1/4 plus 1 over -4, 4 minus 4, I get my 0 over 0. So let's try to combine these fractions. I have 1/4 plus 1 over x, and this, I'm going to go ahead and do this on the side. When you do scratch work, just make sure that you put it over on the side of the page. You don't have to worry about your scratch work being perfect, like with the limit notation and things like that. But if you're going to do just work on the side, make sure it's physically on the side of the page. So 1/4 plus 1 over x, my common denominator, I would multiply those denominators together. So 4 times x is my common denominator. That means that first fraction I need to multiply by x over x. The second fraction I need to multiply by 4 over 4. So when I add these, I get x plus 4 over 4x. So let's go back to our problem. My numerator is now x plus 4 over 4x. There's nothing I can do with that denominator. That 4 plus x, I can't combine anything there. So that's as simplified as it's going to get. And really, this 4 plus x is a 4 plus x over 1. If I wanted to think about my keep, change, flip, if I want to try to simplify this out. So dividing by 4 plus x is the same as multiplying by 1 over 4 plus x. Now we have to remember our goal is to reduce this fraction. Our goal is to simplify the expression. I'm looking for ways to simplify, and it's easy to miss because they're not written in the right order, but this x plus 4 and 4 plus x, those are equal to each other. Those are the same. That means that we can reduce them. So we look at what we have left. We have 1 over 4x. Once we reduce the fraction, we try to plug in our value again and see if we get a real solution. And this time we do. So it looks like my answer is 1 over negative 16.